Hello everybody, Adam Lusek here, and today we're going to be talking about Swarm, which is an experimental showcase that OpenAI released that demonstrated a new way of actually looking at multi-agent orchestration. Now, we've looked at a lot of different agentic applications on this channel, like the agent supervisor, different multi-agent collaborations, or just single agent kind of approaches, but Swarm does something a little bit different. Instead of relying on things like very strict state graphs using stuff like LangGraph, Swarm is actually more for optimizing the traditional function or tool calling agent. And while these simpler setups of just having a language model with attached tools that it can call and execute on are useful, I found that in the past, they've generally been a little bit unreliable for more advanced workflows. So that's why I've strayed away from just using very loose LLM plus function calling capabilities and packaging them up as agents. But after reading through, testing, and trying out some of the approaches that they propose in the Swarm repository here, I think I might be converted back to the regular function calling agent. So let's dive into this and show how you can apply some of their techniques while creating agents of your own. So the problem that the researchers here are trying to approach are really the limitations of scaling up the traditional function or tool calling agent. And they noted that this framework is generally good when you have a very narrow scope to the process that you're actually trying to solve or your workflow that you're applying your agent to. But then the issues actually arise as you complicate and widen up the scope of your agent, adding on maybe additional tools or a larger system prompt to try and cover more areas while creating something like an assistant. To better understand this, let's give an example. Say we have a support chatbot that handles refunds. We can have a system prompt that outlines the whole process of guiding a user through the return policy, one single language model, and then multiple tools directly related to returns. One might be processing the return, one might be sending out an email related to the return, but it's all very focused around that one capability of completing this return process. But let's say we want to improve the functionality of our support assistant. So not only do we want it to handle returns, but now we also want it to give relevant product recommendations. So adding on to our system prompt, we would then add in instructions for if the person is trying to do some shopping, guide them down and give relevant product recommendations. And then we might also add in some tools of like gathering different relevant products from a database or looking at the customer information to try and make some sort of recommendation. But we know our users don't necessarily just want to refund things, and they don't necessarily just want to look for things and buy things. They might also want to handle something about their different account, like changing a password or having difficulties updating their information. So we would have to add that back into our system prompt, add in some more tools for calling the respective things to maybe update information or fix something, and you can kind of see where this is going. So as we widen up the functionality of our assistant here, what we're doing is just adding on more tools to the single LLM and adding on a much more complex single system prompt. And generally, if you've tried to do this and if you tried to add multiple functionalities that cover different capabilities within the same prompt, within the same agentic flow here, it's likely that you've run into the problem of the language model not necessarily adhering to all of the steps and all of your different specific routines that you're creating, and not being able to super effectively help in each one of those specific capabilities. So the researchers noted that, as we were mentioning, for very narrow scopes with limited tools and a specific system prompt, these traditional function calling agents are actually really good at executing on their given tasks. So to capitalize off of that, why don't we break down all of the major capabilities of the system that we're trying to build into very specialized, smaller sub-agents? Each one of these sub-agents is going to be a decomposition of your original routine or your original process that you're trying to complete into those specific individual agents that can cover them and have the specific tools to handle those requests. To do this, they propose essentially just having the dynamic swapping of system prompts and tools. So you're maintaining all of the historical user AI messages over your conversation history, but depending on what the user is trying to do, we're going to swap in those specific prompts along with the tools to help them complete the different tasks. This allows us to create a very seamless conversational flow where as different intents from the user actually pop up, we're going to be dynamically inserting and taking out and changing these prompts and tools so that whatever task we're trying to accomplish in the overarching agentic structure can be better executed on by the specialized agents. To synthesize this nicely, the Swarm approach is really looking at agentic frameworks as dynamic, context-aware switching between specialized agents to handle complex, multi-domain conversations more effectively. Where this dynamic switching is actually referring to the ability to change agents mid-conversation based on the evolving needs of the user's interactions. It's going to be context aware because we're maintaining and transferring all of the conversation history between the agents, which will ensure our continuity and coherence. We'll be using focused domain-specific agents instead of a simple generalist catch-all. And in doing this, this really addresses the challenge of handling conversations that span across multiple topics or require different types of expertise. We'll get into the specifics here in a second, but as a plus, one of the things that you might start to think about is that this really allows the dynamic switching between specific workflows. So as you're decomposing these workflows into individual things, it makes it easier to really specialize, add on to, or tune the different system prompts or tools for specific workflows, making this very modular and scalable. And the main theory behind this is really the idea of the routine and the handoff. Routines in this case really capture that overall flow of what you want your agentic structure to follow and complete. For my example, I'm going to be demonstrating the creation of a generalist meal planning assistant. The routine then that I was thinking for this might be something like this. First, we need to understand the user's meal planning needs and preferences, taking note of any dietary restrictions, also taking note of any dietary preferences. We're going to want to then generate some meal ideas based on these preferences and restrictions, discuss all of the different preferences, and then take notes of the agreed upon meals based on that. I also want to probably create some recipes for these chosen meals, find out what the user needs help making, and take a good note of all of these recipes that are needed for the meals. On top of that, I also want to maybe compile a grocery list for all of these meals, looking at the recipe and what we've thought of, take note of the ingredients that we need and writing them down. And finally, it would be nice if we could, after this conversation is done, generate some sort of final report summarizing the meal plan, recipes, grocery lists, and all of the good things to determine whether or not we're satisfied and output this final thing in a nice takeaway. But as we were mentioning a little earlier, the main issue here is that within this routine that we have, there's a lot of different operations that need to be executed and little bits of small actions that I want to be able to take accurately and effectively. So using a single prompt, it would probably have to be something very long to really outline everything that we want to do to understand the meal planning, everything that we want to do to generate meal ideas, also all of the different instructions for creating the grocery list and doing all of that. And creating that would just probably be a little bit overwhelming. Not to mention that the actual tools needed to do all of these things, like taking the different notes and creating the recipes and stuff like that, would be numerous. So this is then where we can actually break down our routine into subroutines, introducing then the handoff. We're basically going to be looking at our overall routine, breaking it down into the specific parts that we want to specialize in. Each one of those is then going to become an agent. And then what we're going to do is hand off the conversation between all of these agents to handle all of these specific functionalities. So from my main routine here, I went ahead and broke it down into 3 parts. The first routine is going to be actually our triage or our orchestration part. It's going to be the generalist that can actually direct our user queries to the appropriate specialized agents, suggest different possible actions, and then also this is where I'm going to attach the ability to generate that final report. So that should handle a lot of our general asks and then also be able to route our asks toward our specialists, which the first one is going to be our meal planning subroutine, where in this is where we're going to actually gather and note different dietary preferences and restrictions, and then also ideate back and forth with the user to suggest different meal choices. it's then also going to record down all of those agreed upon meals. And then our final routine here is going to cover the rest. It's going to be our recipe creation and our grocery list compilation. So this subroutine is going to be specifically for creating the detailed recipes for the chosen meals, saving those recipes, and then adding all of our required ingredients to a grocery list. And so handing off our conversation back and forth between all of these agents along the different steps is really going to maintain the context and understanding of what we're talking about, but allow each individual language model to perform its different specialized functions or tasks. And this approach is really going to enhance our system's ability to handle these complex tasks while maintaining focus and efficiency at each stage of the process that tends to get lost when you try and combine this all together at once. So to translate that back into something like our diagram, we're essentially going to have one triage system prompt, which is going to be our first agent here in our multi-agent orchestration, that has the ability to hand off the conversation either to our meal planner or our recipe and grocery agent, or the function of actually generating a report. Our meal planner is going to be hyper-specifically designed for this meal planning with the additional tools of noting the preferences, noting the meal choices, and then also the ability to return the conversation back to the triage. And similarly on the recipe and grocery, it'll have the tools of making a recipe or adding to our grocery list, and also returning back to the triage system. So now with the planning and idea behind our assistant down, let's actually install Swarm and start putting it together. Now to get started actually coding this with the Swarm package, first going to install it using this line here. And then the first step that I have is actually defining the tools. So as mentioned, I'm going to have 5 strictly defined tools for our 3 agents. Our triage is going to have a generate report. Our meal planning is going to have the ability to call a function to note down the preferences explicitly and also note down the meal choices. And then our recipe and grocery agent here is going to have a function to make the recipes and then also add to their groceries list. And these are all going to take the form of a Python function. When we get down to actually creating the agent object, we can see that they're just going to be able to take in the Python function, which is a super nice thing that the Swarm repo does. It converts your functions automatically into a tool calling schema. If you're unfamiliar with the intricacies of tool and function calling, I have another video where I break it all down from the top. That'll pop up on screen now. So feel free to check that out if you need a refresher. But most of these functions are going to take the form of this. We're going to have some sort of descriptor that's going to be passed so that the language model knows what this function actually does. And then for actually taking note of all of these things like our preferences and meals, I'm just going to be appending the text to a text file, as well as saving it in a dictionary format with a dictionary that we'll talk about in a bit called context variables. We also, of course, are going to need a message that's returned once the tool is called so that the language model knows what actually happened. And for a lot of these, since it's not actually, retrieving context or anything like a RAG function might, we're just going to return whether or not it's been successful. So pretty much all 4 of the main tools that our 2 agents down here, meal planning and recipe and groceries, are going to use follow exactly the same thing, just inserting something into some specific file and then also the dictionary and returning that it's been successfully done. We also have the generate final report, which is going to be able to take in all of those context variables that we were saving and just create a very simple text file that puts it all together. Now that we have all of our nice functions generated, we now need to take advantage of function calling one more time to actually determine how our conversation is going to be passed off or handed off between all of these different agents. And the cool trick here is that we're actually going to handle the handoffs as function calls themselves. So we're just going to have functions that define to transfer back to triage or transfer to the recipe or transfer to the meals agent, along with that short description of what it's going to do, which of course these are just going to transfer to their respective agents. And then we're going to return the agent object that we'll define in a second here. I really like this because it's a super neat way of just taking advantage of the ability for function calling to handle this dynamic handoff. And language models now are pretty decent at understanding when it's actually time to transfer to something different because of the system prompts. And the system prompts, I would say, are really the heart of this system, because this is what we're going to be passing with their respective specific tools back and forth across the conversation. And being able to break down our main routine into a bunch of smaller routines and then have respective system prompts for each of them allows us to really define and drill into that one narrow capability. For this example, I first have the triage system message, which is going to be our main starting point agent here that will handle most of the conversation, telling it things like you're handling the conversation, try and figure out the intent of the user and call a tool to transfer to the right agent, don't necessarily handle these requests yourself, and ask, leading questions to figure out what the user wants to do. And then also finally, you have the ability to compile the conversation into a report. If it looks like the user's at a good stopping point, you can suggest this. For our meal system message, I have here a meal planning assistant. Always take note of preferences or restrictions. Follow the following routine. Find all the restrictions and preferences, making note of them. Help ideate different meal choices. And then I try to have it get at least 3 diverse different meal choices. Along the same lines is the recipe system message, which states you are a recipe creation assistant. Follow the following routine. Determine what meals the user would like to get recipes for, create those meals and store them. Make sure to add ingredients to a grocery list. Make your responses subtle and natural. And then one of the things that I have here too is that at the end of both the meal and the recipe system prompts, once you have those 3 meals, transfer back to the triage agent. Or at the end of the conversation, transfer back to the triage agent. So you can see that actually being able to break this down allows us to make very modular plug-and-play system prompts for these specific capabilities, such as if I wanted to change our meal planning system, I could just completely change this and try different things out to better execute on our meal planning. So this really makes it a lot better because we don't have to combine all of these into one huge system prompt to try and get one system to do all of this all at once. Combining this together, we're going to be using Swarm's agent function here, passing in whatever name we want, the model, which I'm just defaulting to GPT-4o, the different instructions or the system prompts that we have here, as well as a list of all of the functions that they'll have available to them. So now with everything finally defined and put together, let's actually try it out and run a demo loop. So what we're going to be doing is using one of the helper functions from the package to start at our triage agent and also pass in this dictionary of context variables. Now, while I'm not necessarily using context variables to the full capability that they can actually be used within this platform, they are essentially going to be Swarm's way of handling the actual passage of information across different agents. So you can use them to either be variables that the agents can modify or even pass in existing information that you might want to dynamically insert in, such as maybe, customer information if you wanted to personalize responses at the start. I'll have a link to a lot more demonstrations that Swarm has actually put together themselves that show a little bit more of the actual use of these context variables, as well as a little bit more advanced functionalities. But for my demonstration here, let's actually try it out. So we've started it up. Let's give it a hello. And we can see that our triage agent is the first one that has responded to us saying, "Hi there, how can I assist you today? Here are a few things. I can help with managing your meal preferences or creating recipes." And I'll just say meal preferences. So we can see then that the triage agent actually responded here first, but it's first asking about any specific dietary restrictions or preferences. So let me say I'm allergic to peanuts, which once I do this, you can see that it's transferred directly to our meals agent to start handling this. And our meal agent has already noted down our preference. So it says I've got a peanut allergy. Any other food preferences? I can say also I don't like scallops all too much. And so our meal agent will note that down. And then it's saying, let's start ideating meal choices for you. I'll say, sure, why not? How about a classic grilled chicken salad to start? That sounds yummy. And we can see that the meal agent is going through with its routine, noting down the meals, says grilled chicken salad is on the list. How about an Italian pasta with tomato basil sauce? You can throw it something weird like, tomato basil isn't my fave. What else? How about a creamy Alfredo? Wow, that actually sounds really good. That sounds good. And so that will be our second meal. Then for the third option, we have, how about a vegetable stir fry with tofu? Sounds good too. Awesome. So we can see that it made note of our third meal and then, according to our constructions, transferred it back to our triage agent. So our triage agent now, our general agent, is saying we've added all of this. It says, would you like a report on your meal preferences? I actually don't want the report next. I want some recipes, you know? So now we can see that we've been transferred to the recipe agent, and it says, what meal would you like for a recipe first? I'll say, how about the Alfredo pasta? And what this recipe agent will do, according to its routine, is save the recipe. It also added directly to our grocery list. So it saved the pasta recipe, added all the necessary ingredients to the grocery list. And then it recommends, would you like a recipe for the grilled chicken salad or the vegetable stir fry? Let's do the stir fry. So it'll make that recipe, add it all to the grocery list. Then I'll say I'm good for the chicken salad. All right. But now you can see we're still in the recipe agent, but I'll say I want that report actually. And we can see that we're transferred back to the triage agent. The triage agent executes its generate final report, and now we're all good to go. So then looking back at our different text files that we were generated, we can see that our meals have all of this put down, our preferences have all of this. We can then see that we've got recipes for our stir fry and our Alfredo pasta, as well as a grocery list for all of that stuff. And then our final report here has all of our dietary preferences, the planned meals, and all of our recipes in our grocery list nicely in one file, which is absolutely fantastic. It worked out exactly like we were saying. And what we could see here too is that as I started to actually put in different things that I was trying to do, we were starting to get dynamically transferred over to exactly the different kinds of agents that we set up to best handle our requests. This allowed for a much more focused execution on the different capabilities. Like once I went into the meal agent was directly hyper-focused on trying to get me to agree to 3 different meals. And then it transferred me back out to our triage agent. And then we can see that while the triage agent was asking if I wanted to report, what I did instead was ask for the recipes. And then I was like, oh, yeah, that's cool. We can do the recipes. And then our recipe agent picked up the conversation and was then hyper-focused on actually creating good recipes and adding those straight to our grocery list without any distractions. Now, ideally, in a scenario of an actual chatbot or assistant, we wouldn't see exactly which specific agent we're talking to or when we get transferred or when these different function calls are happening. It would just be one single agent, one cohesive conversation. So you should start being able to see how impressive this is because we can have that one single cohesive conversation transferring back and forth between different specific prompts and tools to better execute on the different individual capabilities of our overall routine. So some of my synthesized thoughts around this, I've written them down here. And what I say is that this approach really optimizes the simple language model plus tools or function calling agent, improving its performance as scope and capabilities start to increase. It's able to leverage language models' adherence to system prompts and narrowly defined routines with specialized tools. And the dynamic swapping of prompts and tools through handoffs enables reliable execution of these complex tasks. The cool thing here is that really decomposing tasks into modular agents allows for the individual refinement of these subroutines, reducing the need for lengthy and unwieldy system prompts or having to completely redesign a full agent system if you want to tweak something. This modular structure facilitates easier maintenance and scalability, and as I was saying, allowing addition of new capabilities without these system-wide overhauls. The result is a more robust and adaptable AI system capable of handling a lot of diverse scenarios efficiently while only needing the built-in function calling ability. That being said, I think that this approach is actually incredibly unique, useful, and I've been getting some really good results of designing both personal and professional agents using techniques like this. So super cool of OpenAI to put out some of this educational and experimental frameworks, showing maybe a little bit of what's to come. All of the code here, as well as additional resources, are going to be linked in the description below. If you enjoyed what you see and you want to see more, subscribe to the channel. If you liked the video, like the video. And if you got any questions or have any suggestions, feel free to put them in the comments below. Thank you and have a great day.